Oh, 4.1. Let's do this. Solving equations and inequalities. This ready part is pretty simple. You're pretty much just graphing this equation, seeing if this point's on it. So if you graph everything correctly, you're just seeing if that one point is where it claims it's on the line, or maybe not on the line. Who knows? I'm gonna say that this is in slope-intercept form, so I know that my y-intercept is -2. My slope, I'm going to rewrite it as 5/1. Hope that's okay with you. So my y-intercept's down here, and I know that my slope is telling me to go over 1 and up 5. So going over 1, going up 1, 2, 3, 4, 5. And then just keep going in that pattern. Again, we could have also gone up 5. 1, 2, 3, 4, 5, over 1. That's another option. Draw a straight line through everything that's there and call it a day. At least for this first part, because we still got a little bit more work to do. So let's take a closer look. You know what? I don't really like that line. Let me do that again. Let me do this. Have it go through them. All right, yeah, that's about right. Yeah, it could be better, you know. Yeah, you know what? That's better. All right, cool. So we're now looking for if this point 1, 3 is on the line. So 1, 3 is going to be actually right here. This is again 1 in the x direction and then 3 in the y direction. So since this point 1, 3 is on the line, and I'll actually put this in green. Since this point's on the line, yes, we can say that this is a point that's on the line. Let's see if we can find one that's not. And I'll actually switch up how I approach this one. So this is asking if 0, 7's on the line, which would be, you know, 0 in the x direction, 7 in the y direction. So 1, 2, 3, 4, 5, 6, 7. So they're asking if this point here is going to be on the line. But if we look closely, and I'll actually switch this up. Let me use this color. Oh, yeah, that's all right. So if we eventually graph this out, we would hope that it's going to hit this point, but it might not. So let's see. This is claiming our slope is -1/2. Our y-intercept is 8. And so we actually see pretty quickly that it's not going to hit, because if we graph this out correctly, going over 2, down 1, over 2, down 1, so over 2, down 1, so on and so forth, we see that it's actually not going to hit that point. And if you're not convinced, draw out this line. You see pretty quickly that it's not going to hit that purple point. So we would say, no, it's not a point on the line, because it's right here, but it's not on the red line. So there's no need to take that further. It's not going to be on the line. Make sense? The set asks us to determine if the two expressions listed are equivalent. Explain your reasoning. All right, let's do 7 and maybe 9 and 10. We'll see. So this is 14, and we're deducting. So notice, deducting. We're deducting all of this here, this 3a plus 2. So we can actually distribute that to show that we're subtracting all of this. So we can really rewrite this as 14 minus 3a minus 2, because think of this as like -1 times 3a would give you -3a. And maybe that's a good way to think of it. -1 times 3a gets you -3a. -1 times 2 gets you -2. And so lo and behold, we actually do get the same outcomes. So we would say they are equivalent after we distribute on the left one in particular. Make sense? How about over here? We see parentheses. Let's break down those parentheses. We have 2 multiplying with everything in here. So think of this as 2 times 2b. 2 times 2 gets you 4. B is along for the ride. 2 times -5 here. So be careful there. 2 times -5 gets you -10. So if I rewrite this, 4b minus 10, they're equivalent. Because this is 4b minus 10, this is 4b minus 10. There you go. Down here on 10 is a little tricky, but I'm just going to distribute 3 in to the top, which gets you 3w minus 27 all over 5. And so this is an interesting one because we have these 2 terms up here and they have this one denominator of 5. So we can actually separate this and say that this is 3w over 5, but then deducting 27 over 5. And so really ask yourself, are these the same thing? So hopefully you're saying that these are not equivalent. Although they have the 3w over 5, they're subtracting 27 here, and it's not dividing by the 5. So we would actually say these are not equivalent. And again, that's because this is subtracting 27. This is subtracting this whole fraction of 27 over 5. That's why. Circle what's equivalent. Yeah, let's do that. Okay. So we talked in the previous example about how we can break apart this into 2 fractions with 4t over 2 and subtracting 10 over 2. So 4 over 2, you can actually rewrite that to 2t, and then 10 over 2, you can rewrite that to -5. So let's think. This is similar to 2t minus 5, but we don't see anything along the lines of 2t minus 5. So that's actually not something that we want to even mention, because nothing looks similar to this. Even if we break this down, nothing's going to look similar to 2t minus 5. You can look closely, but none of our options work there. So let's actually back that up. Nothing's going to look like that first one. However, if we simplify 4t over 2 to 2t minus 10, we see that this is similar to this. Does that make sense? Think about it real quick. Because again, you could have it as 4t over 2 minus 10. 4 over 2 is really just 2 on its own with t, and then minus 10. So it's only these 2 that are similar. All right. With our work down here, anytime you come across a fraction type deal here, use multiplication, divide both sides by your denominator. Trust me on this. This will get you 4x minus 2 equals 20 times 5, which is 100. And you have a few ways you can approach it. You can distribute in, get 4x minus 8. You can add, and this should actually look like a SADMET problem, because you can add 8 here. 4x equals 108. Divide both sides by 4. 4's cancel. X is going to be equal to, what's it, 27? There you go. Over here, I'll help you out. Multiply both sides by 5. Get your 5's to cancel there. For this, divide everything by 4. And then see if you can solve it like this. X over 5 minus 2 equals 5. See if you can solve that. And then use SADMAP. You know what? I'm actually going to stop here. This video was kind of long. If you have any questions, holler. Let me know.